This new theorem is called side angle side similarity. So you can shorthand, you can do it this way, and that's a theorem. Okay. So a theorem is something that you can prove. Postulate is something that you kind of accept as fact. Okay. Okay. So we need two sides and an angle in between. So this has to be in between. So that has to be in between. So if I can find two sides that share proportion, right, then the and an angle in between that is congruent, then I can say the triangles are similar. Okay. All right. So the proportion has to be the same on two of them, and then an angle in between those two sides. Okay, those corresponding sides. Okay, and then we also have this one, the side, side, side. So as long as all three proportions are true, okay, they have the same scale factor, then I can say that the two triangles are proportional. Okay, so we have two of them that we're going to do here. Okay, so we want to verify triangle similarity. So here we have two triangles, and so here we notice that we're not given any angles. So because we're not given any angles, we want to use side, side, side similarity. Okay, so I need to match up which one goes with which. So maybe I need to turn one and see that, okay, maybe V and T go together. So maybe these two angles are probably going to go together, right? And then maybe, look at the numbers here. So we got 9, 12, and 15. So it goes 9 is the smaller one. So which one's the smaller one? So 6. That means 6 and 9 go together. So 6 over 9. And then middle to middle, 12 and 8. So 8 because I did 6 first. So I want to do 8 first over 12. And then lastly, largest compared to largest, 10 to 15. And then I just get in my calculator and I just prove that these three actually are reduced down to the same thing, which is 2/3. So they all have the scale factor of 2/3. So then basically my work is right here. That shows it, and then I can say, okay, by side, side, side similarity, right? And I would say the two triangles, say STU is similar to, well, what matches up with S? Well, matches up with S would be X. T is S, and then U is W. I think I just mixed those up. B, not S. B. There you go. So I'd say that. So maybe a little bit more work would actually say this 6 is ST over VX, kind of like that. Actually, it would be backwards, XV equals, and then I'd set up this one, and then set up this one, and then say they all equal 2/3, something like that. Okay. All right. I think that's it for that one. All right. Part B here. So here you might have to redraw this, right? So maybe redraw this. This is L, this is K, this is P, this is 12, this is 8, and I don't know this one, okay? And then draw the bigger one. The bigger one, I guess I can do it in blue, right? 8 plus 2 is 10, so this whole thing is 10 from K to N. And I don't know this one, but I do know 12 and 3 is 15, so this K to M is 15. So now matching up these two, I only have 2, so that means I'm going to do angle or side, angle, side similarity, because I only have 2 sides, right? So working with this one, the 2 sides would be 10 and 8, right? So 10 and 8, and I'll make sure that equals to 15 and 12, which those reduce down, right, to 5/4. So those are both 5/4, so that's true. And then the second part is an angle in between. Well, angle K is angle K, right? So angle K is congruent to itself. Every angle is congruent to itself. So therefore, I have my 2 sides right here. I have my two angles that are congruent. So then by side, angle, side similarity, these two triangles KLP is similar to triangle KNM. Okay, and that's how you do that. Then you can go ahead and practice this one. So look at the number of sides, see how many you have, right? If you have all 3 sides, then you're doing this one. If you have just 2 sides, then you're doing this one. You got to find that angle in between. Okay.